Hello and welcome to my talk this evening. My name is Monica. I'm a Scala developer and I'm about 2 years into my career. Most recently, outside of work, I've been helping to contribute towards a book about teaching software design using functional programming. The language that was chosen for the book is called Roc, which is a fairly new FP language, which has an easy-to-learn minimalist syntax. The content of this talk is going to be a condensed-down version of what is going to be in my chapter. And I want to show you how we can write a clean, reusable JSON decoding library in Roc. We're going to be decoding from JSON to some data type, which means the logical first place to start would be with a representation of JSON. For the simplicity's sake and for the purpose of this talk, I've chosen not to include all of the types represented in the JSON specification. So this is by no means going to be a comprehensive model, but it'll be enough for us to be able to build intuition on how we do JSON decoding and how we can identify different patterns we'll want to pull out into our library. Typically in functional programming, you would model something like JSON using sum types, where you have an OR relationship between different variants in the type. In Roc, the syntax you use for that and the concept they use to model things like this is called tag unions. So you have a tag called JSON, which has each of its variants in between square brackets like this. In my representation of JSON, I have three primitive types. So we have a string, which contains a string payload, a number, which I've chosen to represent as an unsigned 64-bit int. Then we have a boolean, which contains a bool. We also have two more complex types. We have an object, which contains a dictionary of key value pairs where the keys are the name of the fields in the object and the values are just other JSON values. And finally, we've got an array which contains a list of JSON. Now we know what we're decoding from, let's have a think about what we can decode to. So we're going to have a look at the data in its raw JSON format first of all, in order to be able to understand the shape of it a bit more before we model it. Imagine you have a request where it returns some information about students at a university. Your JSON object is going to have a field called students, which contains an array of objects, an array of student objects. Each student has a name, which is a string. It has a field called modules, which is a list of the module object. Each module has a name, credits, enrolled fields. Then we have a grade field as well. Finally, in our JSON, we have the ability to parse data about two different types of student. We have a graduated one and a current one. And I'm using the hash type discriminator in JSON in order to differentiate between different subtypes in our student data type. Now we understand the shape of the data, the shape of the JSON, let's have a think about how we would model this in Roc. Seeing as we're going to want to decode from JSON to some data type representing the student data. We're going to start with the simplest thing that we have in our JSON data, and this is a module. Module is going to be represented in JSON as an object, and the mapping between the JSON data and how you would do this in Roc is objects can be represented as records in Roc. So for each field in my JSON, I'm going to have a corresponding field in my record. So I've got a name, which I'm representing as a string, credits, which is an integer, enrolled, which is a boolean. There we go. And we can now move up to the next level. So now we can have a look at how we model a student. Again, student is going to have a name field, which is going to be a string. It's going to have modules, which is going to be represented by a list of module that we've just modeled. Then we're going to have grades, which again is going to be an integer. And then finally we have this hash type in our JSON that we've not kind of covered this part of the model, and we've not covered this part of the data in our model yet. The way we would do this in Roc is by using, again, tag unions. We're going to have a tag union called student, and then we're going to have two variants, which are going to be current student and graduated. So far, we've managed to model our JSON using tag unions. We've had a look at our data that we're decoding to using tag unions and records. Now let's have a think about how we can decode from one to the other. I'm obviously not just going to give you the answer straight away. We're going to go on a bit of a journey and take the scenic route to get there. So we're going to start off with thinking, how can we decode the simplest thing in our model, in our data, which is the module? We're going to have to write a function that parses from JSON to a module. And a really quick aside, this is how you do function declaration in Roc. You just have the name of the function, followed by input parameters, arrow, output parameter types. And we're going to call this function read module because we're trying to parse from JSON into our data type. However, not every valid JSON input that you have is going to have a correct successful mapping into our data type. There's going to be some JSON values that don't have any of the fields in mod that we need. We need to take this into account when we're modelling this, and Roc has a data type called result, which helps kind of capture functions like this when they can fail, when it's not always going to have a correct mapping from one to the other. Result has two variants. It's quite similar to either in Scala. You have an OK, and in our case, this is going to be a module. Then for the error case, you are going to have this error tag. We need to have a think about how we're going to model the errors that we could come across. So the first thing we could do is just return a string. This is a good enough start, but it's not very informative, and we could do a bit better than this and use something that would allow us to better make use of Roc's functional features. The solution that I came across was using tag unions. So for now I have a tag called decoding errors, and to begin with we'll just have one tag that says cannot decode JSON, and it has a payload of a string for you to give it a bit more information to the user. As we come across more things that can fail and things that can go wrong, we'll enrich this data type and we'll add to this tag union in order to give some more information to the user about what's gone wrong. We're going to use this type as our error type, and this gives us a pretty good starting point in order to write some code. So let's do just that. We know that we're going to be taking JSON as an input, so this is how you define the body of a function. You have your backslash and then JSON and an arrow. We know that not all JSON inputs are going to have a valid mapping to a module, which means we're going to have to pattern match on JSON, and Roc uses the when is syntax in order to do this. Then we're going to have two cases. We're going to have the happy path, where the JSON coming in is an object because we're trying to decode to a record in Roc. And then we're going to have an underscore to represent all the other types in JSON that we know are going to be the incorrect shape for this incoming JSON. This is our first opportunity to enrich that error tag that I was talking about. We've come across another one called wrong JSON types, where we can simply just add this to our tag union like this, and then this will type check, and we can return this value and it will kind of all work out. Now, the error message that we give back for cannot decode JSON, or wrong JSON type, is not the most informative. So I'm going to write a quick function called type to string, which simply takes a JSON and returns a string, and it just pattern matches on that JSON to give you the stringified version of the type. Now we can get back to our happy path. The payload of the object fields, we're going to want to make sure that this contains all of the fields that we need in order to decode a module. We want to make sure it's got a name, credits, and enrolled. The easiest way to do this is to call get on the dictionary. This is the function from Roc standard library. And the return type of this is going to be a result of either the value you're trying to get or an error telling you that the key wasn't found, which means we're going to have to do another pattern match, which I'm going to put here. We know that we only care about this decoding to a module if this isn't okay. And then we can also be a bit more specific and say, I only want to continue parsing if this value is also a string. Then for all other cases, we know we want to fail and say, we've not found this field. And we can add this again to our decoding errors tag union. Now we're going to repeat this same pattern over for the other fields. We're going to do this for credits, which we're expecting to be a number. We're going to do it for enrolled, which we're expecting to be a Boolean. And then when we have access to all three values, name, credits, and enrolled, we can then build the module records. And finally, because we know that this function has to return a result, we have to wrap it in an OK. Now we have a function which, given a JSON, will return us either a result of a module or some decoding errors. Next up on the journey of decoding is going to be how can you decode a list of modules. So we're going to write a function to do just that. We're going from JSON to a result of something or decoding errors. We're again going to take in JSON as an input, and again we're going to pattern match on the shape of the JSON. We only care when this JSON is an array, and we're going to use Roc's map_try function in order to iterate over this list of JSON. Oh, that's gone. List of JSON. Can you hear me in the back? Is that okay? Okay, cool. Sweet. So we're going to use Roc's map_try function, which allows us to iterate over a list of something and attempt to decode each element. So the signature of map_try is if you have a list of elements and then you have a function which goes from each element to a result of OK or errors, then it will return to you a list of either, or a result of either the list of the OKs or the first value, the first error that it came across. And just like that, we have a simple read modules decoder for a list of modules. Following the same process, we're going to do the same for read student. We're just going up a level in our JSON data that we saw in the beginning. Much the same, the kind of same patterns. We're matching on the shape and then we're trying to get the fields. So for student, we need to have name, modules, and grade. Then we're going to use the function we just wrote, read modules, in order to decode the modules field. Then we also have to take into consideration this other field in our JSON, hash type. The way that we're going to decode this is we're going to get the fields and then pattern match on the actual value of the string to tell us what we should be decoding into. If the value is current student, then we should be building a current student records. For graduated, we do the same and we create a graduated student record. And then all other cases, we can return an error to the user to say that the decoding failed and the reason why. And again, like we did for read modules, we need to do the same for read students because we're decoding a list of students. And here we're going to use the function that we had that we've just written, read student. And then finally, we need an entry point into the decoding. So our request in the first place is going to be the JSON object. So this is the type signature for that function. Doing much the same thing, we're going to be pattern matching on the shape of the JSON and making sure that it's an object, and then it contains a field called students. And then using our read students function that we've just written. So we can chain all those together and we get this monstrosity, which it wasn't very fun to write, it's not very fun to read, and I would not want to maintain it. You can see that we have a pretty simple data structure, and you can see that if this was to get any more complex, then the code that you would need to decode this JSON would just get more and more difficult to read and understand and maintain. So let's think about some ways that we can improve this and kind of pull out some patterns that we've seen. At this point, we can see the couple of the problems. We have lots of boilerplate error handling code that's mixed in because Roc compiler, when we're doing a pattern match, if we're checking for one of the shapes, then it forces us to handle all other cases of that JSON type, which rightfully so. We want to have exhaustive pattern matches. We also have a lot of mixing of the very specific concerns of the domain, so the actual how do you create this record for a student or a module, mixed in with the error handling code that is actually quite generic and can be used in lots of different applications. So let's see how we can separate these two out. Every function that we've had so far has started with a pattern match and we're checking the shape. So let's write a few helper functions in order to be able to call these functions rather than repeating the same code all over the place. We'll start with primitives. We're going to have a function, a string decoder, which is a function from JSON to a result of a string or decoding errors. And again, you should recognize the pattern. We're checking the shape of this data and returning either the value we find or the errors about what went wrong. Something to note before we go any further is we have this pattern that's repeated all over the place. We have a function signature, which is JSON, to a result of some type or the decoding errors. When we see this kind of pattern cropping up all over the place, sometimes it can be it can be a lot nicer to work with if you give this a type alias. So from now on, I'm going to call this function signature a JSON decoder of t, which is just a function from JSON to result of t or some errors. But just remember, it's a function for decoding or parsing the JSON. Following a similar process to the string, we're going to do the same for our other two primitives for our Boolean and our number. Cool. And then we can move on to the more complex types that we had in our JSON structure. So we'll start with decoding arrays. If we want to have a decoder for an array, a JSON array, they're going to need to satisfy the following two conditions. First, we're going to have to check the shape of the JSON and make sure it's an array. Then we're also going to have to let the caller decide what type of array do they want to decode. If they want to decode an array of strings, they have to tell us how they would decode a string. Something to note is that we've actually already written two functions that do exactly this for the first point. We have read modules and read students, which decodes a list of modules and students respectively. So let's take one of them and make it a bit more generic and see how we can reuse some of this code we've already written. We're going to pass in another parameter. We're going to pass in a decoder. And the body of the function is itself a function, so that's why we have JSON returning something that's going to be a result. Then we can use this decoder that we've just passed in instead of the read module function. Then we can do some renaming, because this is actually now an array decoder, and the values in the array payload are actually JSON values, not modules. And just like that, we have an array decoder. We've made this a lot more powerful quite easily and quite simply, and more importantly, it's reusable for the different lists that we were trying to decode. So let's see it in action. We can take all this code and replace it with this line. So we have a call to array, and then we pass the read module function, the read module decoder, and then we explicitly pass the JSON to that decoder. We can do some tidy up for our other read modules and read students. So it takes us to this. And then we can move on to our last data type that we've got in our JSON representation. We're going to move on to decoding objects, which, if you remember, are just a collection of key value pairs. And we want to be able to decode objects into records. So the first thing we're going to need to figure out is, how would I do this for an individual field? How do I do one field and then I can aggregate that together and decode an object? As before, this new decoder is going to have to satisfy the following two conditions. First is that the shape is going to be an object, so that we can have access to that dictionary of key value pairs. Then the caller should also provide us the name of the field they want to decode, as well as a function to decode the value with. As with arrays, we've actually already done something that satisfies this first point. Hopefully you're seeing a pattern start to emerge. We're going to take this and make it, mix back, nice. We're going to take read requests and make it a little bit more generic. We're first going to pass in two new parameters. We'll have field name and decoder. Then it makes sense to do some renaming. So we'll have, this is actually a field decoder now, not a read request. Then we can use field name, which is now going to be the key that we try and get the value from the fields, which is the thing we're going to want to decode. Then we can actually enrich that error message a little bit and make this more dynamic rather than hard coding the field name. Then this is actually now field values. And finally, we can now use the decoder that we've passed in. So we have a field decoder, which, given a string for a field name and a decoder for decoding the value, will give you another JSON decoder. So we can see it in action. We can replace all of this code with the following. We're going to have 3 decoders, one per field of our module record. We're going to have one for name, which you call field, you pass the field name, and then you pass a decoder. For name, it's going to be a string decoder. The same for credits, except we'll be using number, and then for enrolled, we'll use Boolean. But we've actually kind of broken something here because we no longer actually have access to those values of name, credits, and enrolled, because what's returned from that call to the field decoder is a function from JSON to a result. So we need to think of a way of how we're actually going to combine these different decoders together and get the values out of it. If we had to take a step back and think about it, we only want to decode a module if all 3 of these decoders are successful. This tells us that we're going to need we need to come up with a way of combining multiple decoders together and being able to access their successful fields. Again, we're going to have to satisfy some conditions for this function. The first thing we want to do is the caller has to tell us how are you going to actually build this record that you're trying to combine decoders together, and what do you want as your output. The next is the caller should also give us decoders for each of the fields in the record. Let's say, for argument's sake, that we're trying to combine 2 field decoders. The type signature for a function like this would look a little like this. So we have an input, our input parameters are going to be a tuple of a string and a JSON decoder of A, another tuple of a string and a JSON decoder of B, and then we'll have a function from A and B to C. And then our output type is going to be a JSON decoder of C. That'll be the combined output decoder. But this should jog your memory a little bit because we've already written a function which kind of does something a bit similar to this. When we wrote fields, we were taking in a field name and a decoder, which is a string and a JSON decoder, and was returning you another decoder. So what could we do in order to avoid having to rewrite that function in the body of this multi-field decoder? What if instead of forcing the caller to be decoding fields, we just let them decode anything they wanted? If they can provide us a decoder, then we'll be able to combine them together for them. So this is the type signature we're going to try and write some code for. We're going to call this multi, and it's going to take 3 parameters, as I explained in the type signature. We've got decoder A, decoder B, and F. Then we're returning a JSON decoder, so we have to have a function as a return in the body. Then we're going to try and we're going to apply JSON to the decoder A to get res A. We'll do the same for the second decoder. Then we only actually want to return a result of an OK for this multi-decoder function if both of these decoders are successful, if they're both OK values, which means we're going to have to do a pattern match on res A and res B, which is exactly what we're going to do. So our first case is going to be when they are both OK values and we have access to A and B, which means we can then apply F to A and B. Then if the first decoder fails, we'll have an error of A and we'll return that. And then we'll have an error of B and return that in the last case. I'm going to do a bit of cleanup. So res A and res B can just be inlines like this. And hopefully you should start to kind of recognize this pattern. This actually has a bit more of a common name. This isn't multi, but this is map2. And I have implemented map and map3 in a much similar fashion. So map uses the map function for result from the Roc-Solid library. And you could do up to map n, but for the purpose of this talk, I only had to do for map3 for the 3 fields. So this is the point where we got stuck before. Now we can rewrite this and we can say have a module decoder. We're going to call map3. Then we're going to pass in our 3 decoders for each field. We'll have name fields, credits, and enrolled. Then we're going to have a function to say, this is how you would build this record. This is how you would build a module. By taking those successful values, name, credits, and enrolled, and passing it into the record in Roc. And finally, we have to pass JSON explicitly to the module decoder. If we do a quick recap of what we've seen so far, we've been able to write a decoder for individual fields. Then we've been able to combine them into, we've been able to combine together multiple fields in order to decode objects into records. So what's left still to do? If you ever think back to the JSON data we saw in the first place, there was this other field called hash type that we've not actually been able to decode yet. This allowed us to discriminate between different subtypes of student, and we need to come up with a way of being able to decode this. So the first implementation I came across was, I either have a current student or a graduated one, so let's write an OR decoder for this. Oh, sorry, skipped ahead a bit. This was how we were doing it before. We were decoding hash type, and then depending on the value, making decisions on decoding. And instead, we could do an OR decoder. So my OR takes the first decoder, and then another one, and then it's returning a function from the body, so we have JSON. Then we're going to try and use the first decoder, pattern match on it. If it fails, then we're going to try our other decoder, and if it's successful, we'll return that value. But the problem we were trying to solve wasn't just an OR relationship between 2 different types. We want to make this a bit more general and be able to use this decoding library for any of the tag union types. So that means we're going to need to be able to decide between more than 2 decoders. So, quick aside, we're going to clean this up a little bit and introduce another one of the functions from the standard library. Because we're just pattern matching on, we're making a decision based on if the first decoder fails, we can use the onError function from result in order to decide what to do when we come across an error. So onError, which takes a result of a function from one error to a result of a or another error, and will return you a result of a or other error. And there's our OR decoder. But as I said, we're trying to decode tags which can have more than 2 types in them. The solution that I came across for this one was using a decoder for tag, where I'm going to pass in a dictionary of decoders. So I'm going to have a dictionary of key value pairs where the keys are the name of each of the tags in the union, and then the values are going to be a decoder for each of them. Again, we're returning a JSON decoder. We have to have a function returned from the body of this. Then we're going to try and decode the hash type fields, and we're going to use the string decoder for this. We can then do some pattern matching. We know that we are expecting this to be a successful value. So for an OK of a tag name, we can then use this. In the other case, in the sad path, we have to tell the user that we were not able to find this field, the hash type discriminator. When we go back to the happy path, we're going to use this tag name as our key for getting from the dictionary of decoders that was passed into the function. We're going to use this pipe syntax from Roc. So this essentially allows you to chain together multiple functions. So pipe will take the value from the previous call and pass it into the first parameter of the next function. So you can just see it would be onError, and then you would pass in the result from the line above, and then you would pass in the second parameter, which is a function from some error to another error. Then we are going to attempt to actually use the decoder that we find in the happy path. So result.try takes a result, and then a function from A to a result of B, an error, and returns a result of B or error. And this leaves us with a nice tag decoder, which we can use to try and streamline our verbose solution. We can take what we had here and replace it with the following. We're going to have to write a decoder for a current student, a graduated student, which are both just calls to map3 in the same way we had before. Then we're going to populate a dictionary to pass into our tag function call. And again, we're going to use that pipe syntax. And then finally, we'll pass the student decoders to tag and then explicitly pass JSON to it. We can now decode tags, and this was the kind of last thing that we had to come across, so we can pull it all together, and hopefully by the end you'll see that this is a lot more readable when we've managed to kind of chain all of our helper functions together. We're going to start again with the simplest thing in our model, which was modules. So we'll have our read module function, which then we are going to use in the read modules, which is decoding a list of module. Then we'll have a read student, which is going to use the read modules function. And then finally, we'll have read request. So we've managed to half the amount of code that we need in order to decode that pretty simple data structure. And what's nice about this is that it's much easier to understand, and it reads a lot more like the actual JSON that we had in the first place. So you can go through and find decoders for each of the fields that we had in our JSON. So instead of having those heavily nested function calls, which were impossible to read, you have this nice flat structure, which hopefully you'll agree would be a lot easier to maintain if that data structure was to change. So let's round up what we've managed to do today. We started with a decoder for the student data that had a few problems. It was mixing concerns of the domain with the error handling, and it was unreadable and would have been a headache to maintain. In order to fix this, we pulled out decoders for primitive types and for complex types. We then wrote ways for us to be able to combine these together and chain together decoders. We were able to transform our scenic root implementation into something much more readable and enjoyable to read and write. And in the process, we gained a nice decoder JSON library that we can reuse in other projects, and that we're able to kind of take away from all of the boilerplate code that we've had to write. Thank you very much for listening. I am happy to take any questions. And this is a QR code for any of the codes that you saw if you want to have a look. Thank you.